webinar on why IVF lab design matters and blueprint for actually designing an IVF laboratory. We have a very interesting session lined up for all of you today. And like most of our sessions, we try and do something innovative. So today we have not an embryologist, not a clinician who's joining us, but actually a very renowned architect who designs IVF laboratories, who's going to be talking to us about the modern concepts of IVF lab design. Before I begin this webinar, I'd like to thank all of the participants who've registered for this Meta webinar, especially our international participants. We've got a lot of registrations this time from outside of India. I'll name a couple of the countries that we have registrations from: Albania, Bangladesh, Benin, lots of registrations from Africa, Western Europe, Oman, Pakistan, even South America, where we have registrations from Paraguay, Peru, etc. So today's basic like the webinar that we are going to do today is going to talk about only how design can influence success rates. Now, when you see this first illustration on the slide today, can anyone from the audience type in what they are actually seeing? These four illustrations, if you put it into the chat section, what you can actually notice. It'll be interesting to discuss with all of you. Now, what you're actually seeing, these four diagrams that you're seeing today are actually how hospital design has actually evolved um, throughout the few centuries. We started with a quadrangular design from the 1200 centuries to a Greek cross in a square to a circular design. And now we have our high-rise pavilion designed hospitals. And this design was not just influenced by how a hospital should look on the exterior, but it also had a certain amount of medical benefits to our patients. Now, these designs, especially the designs that were proposed by Antoine Petit or Florence Nightingale, actually influenced how medical care has also evolved. And this tells us the importance of architectural design in our fraternity. These wards that you see right here were actually designed by Florence Nightingale, and what she basically brought uh, to the medical community was the influence of natural light in the hospital ward itself, long spacious corridors with beds on either side so that one could see throughout the ward, and basic concepts which we now really appreciate, which actually came from her, was light can actually kill bacteria, can actually help in early recovery of the patient, and can also influence their sleep patterns, can influence how quickly they would enter into a rehabilitatory program, etc. So all of this really teaches us that design does matter in healthcare. This is a flow diagram or an interior blueprint of an IVF clinic. And this also has evolved with time, because if you notice early on, when IVF really started, I'm sure all of you have seen the movie Joy, and you've had certain amount of insights into how IVF labs looked like when IVF originated. It was very different, and it was just a compact room with all sorts of equipment placed in one room itself. There was no sense of VOCs. There was no like nobody really cared much about air quality, particulate matter, about flow of the laboratory, about ergonomics, all of these things. But now when we look at the last 40 years and how IVF lab design has also evolved, we can now see that in these blueprints, there are now segregations for what areas are going to be used by the staff, what areas are going to be used by the patients, what areas have an overlap between these two. We now see entries and exits being planned so that a positive air pressure is maintained between different rooms, especially in the IVF lab complex. We can also see that there might be introduction of certain hatches instead of doors, which allow for minimum access of the area to people. There's less disturbance of people walking in and out of rooms, and this really has changed the way in which we practice IVF, and it has actually helped us to maybe streamline the processes a little bit more. We know for a certain fact that improper lab conditions will lead to environmental stress. And this environmental stress can be in the form of toxins and pollutants entering into the laboratory, or it could be light source, or it could be mechanical stress, chemical stress, temperature, etc. A very clear example of this comes from the recent wildfires that are affecting America. And we've noticed that uh, the embryos that have been exposed to wildfire smoke, or the labs that have been exposed to wildfire smoke, 20% of those cycles have resulted in no blastocysts forming within that laboratory, as compared to 2% in most other laboratories. So this does tell us of how even our environment and the location of the laboratory and the clinic can actually influence our outcomes. Certain important design concepts that we need to think about first is the environmental control that I just mentioned to you. Why it's important is because embryos are highly sensitive to changes in the environment, and these changes can be temperature, humidity, can be air quality, and can be light. We also need to worry about preventing contamination in the laboratory, and I'll show you a couple of instances later on where we've seen contamination in laboratories and the reasons for it. And we also want consistency in our results. This can be brought about by introducing certain checks for air quality. I'm not going to be talking much about all of this because I know our next speaker is going to cover a lot about architectural design, how things need to be done in laboratories. So this is just a brief overview. So we need to think about air quality, and this can be done by introduction of air handling units or HVAC systems into the laboratory. We need to think of temperature and humidity control, and again, an HVAC system really helps us with this. And lighting is also something that we now want to now consider. There are certain instances where laboratories have huge windows which have access to natural light. Now, it's not a bad thing to have those windows because it does impact the mental health of the embryologist, and they do perform better when they have better visuals in their surroundings. But we need to cover it up with a film so that the intensity of light entering into the laboratory and affecting the embryos can be controlled. Whenever a lab is designed, you need to look at workflow optimization. And this is important because we want to minimize risks. We want to time the procedures and not take too long between traveling from one workstation to, let's say, the embryo transfer bed, or from a workstation to the incubator. So we really need to plan accordingly. And then we also want to increase the efficiency of the operator, because if the embryologist is just walking from one room to the other room all day, obviously they're going to get stressed and they're going to get fatigued, and in the long run this might be one of the causes for a burnout. This can be done by ensuring that there is lab zoning. We would want to divide the laboratory. Obviously, the clinic is divided into clean or sterile zones and non-sterile zones, but even within the laboratory, you can have zones for, let's say, dedicated to the ovum pickup, dedicated to transfer, dedicated to ICSI, and sometimes if you have a busy laboratory, you want to have a separate zone for pre-implantation genetic testing and embryo biopsy. The next thing that we want to talk about is ergonomics. This is important because we want our staff and our embryologists to be productive, and their comfort is of prime importance for us, because unless and until you're providing them with a comfortable work environment, which looks after their health uh, and prevents injuries or prevents fatigue, they'll not be able to give their 100%. We want to ensure that there's precision in handling, and we ultimately want to reduce burnout. How can we ensure this? We can ensure this by designing our workstations properly. So having adjustable height desks, chairs, providing sufficient counter space, soft edge furnitures. Most of the times, people in Indian laboratories have stainless steel or aluminum stools, which are not very comfortable for an embryologist who's sitting for long hours on the same workstation and doing ICSIs or doing cryopreservation. So these are small things that can really influence the comfort of the embryologist and ultimately their mindset towards that laboratory. Then we want to think about safety and compliance. Why is this important? Because let's say in certain scenarios of flooding or fire, we would want a good escape plan for our cryopreserved embryos and for our stored embryos and samples from within the laboratory to outside. And if this is not incorporated right from the get-go, it's very difficult to implement later on, and these will influence how you get compliances from, especially in the Indian scenario, how you would get an NABH compliance for your laboratory if you don't have a exit plan and an exit route predetermined. And obviously, you want to think about staff safety, especially like I'll give you an example of the cryo room. Should be ventilated, should have an oxygen sensor, should be spacious enough for the embryologist to work properly without damaging the cryo tanks, etc. So certain things, if thought beforehand, can really help us in improving our workflow and improving the management within the IVF laboratory. Things you want to think about are disaster preparation, waste management, and again, compliance standards specific to your own countries. Then you want to think about scalability and flexibility. And again, this also has to be incorporated into the lab design right from the get-go. Because imagine you've built a laboratory in a 10 by 10 room, and then suddenly your center starts doing very well and you have very high numbers, and your laboratory is not sufficient enough to cater to those numbers. You try and maximize it by stacking incubators one over the other, and then increasing work hours, etc. But ultimately, you're not future ready. So if you have a space that's future ready, where you can scale your operations depending on the demand, or you can incorporate another laboratory. Let's say you started with only an IVF unit, and then you can scale to an embryo biopsy or a PGTA clinic. All of these things, if thought beforehand, can really reduce the downtime that's associated with refurbishment or reconstruction or scaling up an IVF laboratory, and ultimately can make you more profitable in the future. And also, this is something where cost effective growth or the concept of cost effective growth comes into picture. This can be done if you're using a modular design, because these modular panels can actually be rearranged or reconfigured as you like it. And it can also, I mean, with the newer tools that are available, especially AI-based systems, 3D designs, renders, etc., it can give you a good enough idea of how to expand in the future. And I think lastly, what we need to think about is sustainability in design, because it is our responsibility towards our environment now. We need to establish sustainable practices which align with uh, basically safeguarding our environment and using those products which are green. We also need to think about energy efficient systems. And again, especially when we're working in a IVF laboratory, obviously using non-toxic materials, uh, which have minimum effect or minimum harm to the embryologist or the embryos, is something that we want to think about. And these are certain things that we would want to basically do for our laboratories. So with this, I'll leave you with 4 publications. The first one, I'm sure all of you have read. This is from ESHRE. This is Revised Guidelines for Good Practice in IVF Laboratories. And there is a section on IVF lab design in this. The second one is from ASRM. Again, there is a section on IVF lab design on that. I was part of 2 publications, one for the Indian Society of Assisted Reproduction, which talks about safe and ethical practices in IVF clinics. And we've talked about how to design laboratories and the minimum requirements for IVF clinics and IVF laboratories in India. And then we did a similar exercise with Aspire, where we talked about basically lab practices for low and medium resource countries, and again, minimum standards of care for those countries. So all of these 4 publications can give you a lot of insight into how to design a laboratory for your own country, and for your own region. Now, it's my proud privilege to introduce our key speaker for today's webinar. We have with us Charmaine Kai. Charmaine is the co-founder and director of 8i Architects, an architectural practice that specializes in designing healthcare, education, government, and high technical projects throughout Australia. She graduated from the University of Queensland with a degree in design studies and architecture. She is a registered architect in multiple states throughout Australia. For more than 20 years, she has led IVF. She has led design and delivery of IVF clinics and healthcare facilities throughout Australia. She is a Good Design Australia ambassador for the University of Queensland. She's been an interviewer for the Faculty of Medicine. She's been an architectural examiner with the Board of Architects for Queensland, an expert reference group member for the National Standards of Competency of Architects, again in Australia. She's passionate about educating clients about holistic design, from inception, planning, construction, operations to the life cycle of the whole project. She's one of the only architects in Australia who's actually a member of the Fertility Society of Australia and New Zealand, and also of Aspire, and has a special interest in environmentally sustainable design. She is a published researcher at Queensland University of Technology, the Center for Subtropical Design. So with this, Charmaine, welcome to Meta, and welcome to this webinar. And we're really looking forward to hearing your thoughts on the blueprint for IVF lab design success.
Thank you, Keshav. Thank you for the introduction. Hello, everyone. It's good to see that there's so many people who are interested in lab design. Just gonna share. Everyone see that?
Yes.
Okay, so I'm going to start basically with the blueprint of basics and key elements of what you need for an IVF lab. There's many things that you need to consider when designing an IVF lab, but I'm just going to touch on some few key elements that Keshav's actually already mentioned, but I'll go into those into a little more sort of technical details as well. So here is the lab that I've designed in Sydney. It has been designed with most of the sort of modern principles. So this was finished about 2 years ago, this lab. As you can see, it's been set up with time-lapse incubators. We've got the hoods, so it's a combined andrology and embryology lab, this one. And you can see in this, we've got good lighting through it. We have a lot of connections with adjoining labs next door. And we've also got really good quality air conditioning, and particularly the registers that you see here, they're specifically, these are the ones that you want for an IVF lab, simply because they do not push too much air through. I'll go through those in a bit more detail in a minute. So just a quick run through of what I'll be talking about today for elements, just key elements of an IVF lab. The first one is why design actually matters in IVF lab in terms of success rate. Talking about air conditioning, air quality, the building structure, the importance of allowing for gases and power, flexibility and expansion, and the importance of designing an IVF lab for your staff, for workflow, ergonomics, and well-being. So, first of all, why does design actually matter in an IVF lab? When people think about architecture, generally they think about the clinic space, the consulting room space, the lovely soft spaces that the patients actually use and go into, and not necessarily the IVF lab is the first thing that comes to mind that needs a really good design process. It's the IVF lab's basically the engine. If you don't have a good lab, it will affect outcomes. It affects many things that will lead to poor patient outcomes. So things that we need to consider for IVF labs. So what we're trying to aim to do is to improve the environment. So the environment within the lab, the air quality, which has become more and more prevalent in terms of having good air quality within a lab, has been shown through research to make a very big difference. Lighting, to have good lighting, a good colour in terms of the lighting is really important. So not the blue light spectrum. I'll talk about that a bit later. The temperature is actually really important. And then the other thing that goes hand in hand with temperature is the humidity of the lab environment. Why we want to have a look at design in IVF labs is to improve efficiency within the lab. So there's less time and cost wasted due to inefficient movements. To improve the efficiency not only allows staff to spend more time on doing the things that matter, is not wasting time in terms of walking between spaces in between the ET room and the lab or to the theatre and the lab, where we're actually spending time doing what scientists do best. This also provides for the people that are financing the labs that it reduces costs as well. Flexibility and future-proofing, very important in terms of when you're initially looking at designing a new IVF lab or even refurbishing one to cater for growth. I've not done an IVF lab in the last 15 years where the lab has not had to grow at some stage. So really important that you allow for enough power, gases, enough space within the lab to grow without significant disruption, because to construct within a lab basically renders that lab inoperable. The amount of dust and dirt that's created during the construction process, you just can't have a lab running. So to be able to make plans for growth that minimises any disruption within the lab will save you a lot of time and money in the future. Material selection, we'll talk about material selection. So if you have good, robust material selection, it will actually reduce maintenance within your lab. It will also minimise disruption and operating costs within the lab in terms of building it. The other thing that's really important for material selection is VOCs, and I'll talk about that in more detail a bit later. VOCs, it's well documented the harmful effects of VOCs on embryos and gametes. It's something that has been on the radar for a long time, and I'll give you some pointers on materials that, even though they say they are low VOC, because there's a lot of low VOC products, building products on the market now. In fact, if you actually test them, which is what I generally do when I design labs, you will find that they are not to the levels that's required in an IVF lab. The other thing is to improve the well-being of the staff. So it's really important. So having a lab that's actually designed to cater for the comfort of the staff, you'll actually see the benefits in terms of staff retention. You know, staff reducing burnout, they'll actually want to stay if it's actually a lovely environment for them to work in. They'll have increase in staff satisfaction. And the main thing for the business, for any IVF lab business or any business really, is that you get to retain the staff that has built up that knowledge. And in a lot of cases, particularly in IVF, that knowledge is invaluable. To have a high turnover of staff is something that no business, particularly in IVF, in IVF, that you actually want. So all these things combined at a very high level all lead to improved patient outcomes. So the first thing we're going to talk about is air conditioning. So when you are designing a new lab or refurbishing a lab, generally it'll be within an existing building space. If you are lucky enough, you might go into a space that's brand new and purpose built for a lab, but in general, you'll probably go into an existing building. So what you need to have ideally is to have a separate HVAC system, so a heating, ventilation and air conditioning system for the lab. A lot of times labs are co-joined with hospitals. The system for the lab ideally should be completely separate from the hospital system. There are cases where it's unavoidable and you will share a system, but ideally the lab should be in control of their space. Particularly given some of the requirements that I'll go through below, it actually it's not quite compatible with a hospital space or even a clinic space or an office space. So ideally you keep a completely separate HVAC system. So one of the things to look out for if you are looking for a new space and thinking of putting an IVF lab in is to have a look the ceiling height void. So the ceiling height void is actually the height between the top of your ceiling to the underside of whatever structure that the building is. So it might be the roof, it might be the slab, the concrete slab of the floor above. That distance, the more space you can get in there, the better for putting in a dedicated air conditioning system for your lab. As you can see in these photos, these ceiling heights that are there are particularly on the photo on the right, that is about 1.3, 1.4 meters, that ceiling height. So it's quite big, not something you would normally find in most buildings. This building was purpose-built to contain hospital. So they actually deliberately designed quite high ceiling spaces, knowing that there'd be a lot of services going through. So you can see with the amount of ductwork, so those rectangular sections through here, they're all rigid air conditioning ducts. We've got plumbing from the floor above. We have electrical cables. We have fire services, so fire sprinklers. And then we'll have flexible ducts within the space. But as you can see, there isn't a lot of space left after all these services go in. So the more space you can get, the better. And in this photo here, you can see this is about 600 millimeters, so just over 0.5 meter in terms of height. And you can see on the right, that's actually an air conditioning duct. And there is probably only about maybe 2 inches of space above it. So it's really tight, and that's sitting right on top of the ceiling. So the steel you see down the bottom is the ceiling grid that's holding up the ceiling within the lab. So you can see that having as much height as you can is advantageous. It just makes it a lot easier to also clean and change out filters as well. So that's something to think about. So we'll talk about filters. So ideally in the air conditioning system, you do have a HEPA filter, and most labs now moving forward will try to have a HEPA filter. That removes particulates. So ideally for an IVF lab, you want to add things like activated carbon to reduce the VOC that does build up within labs over time, potassium permanganate, a UV filter to kill off microbes as well. And then think about fresh air intake. So the amount of fresh air intake into a lab is generally a lot higher than your normal air conditioning. So with that fresh air intake, there are things to consider, particularly the filter that goes into the air conditioning system from the fresh air intake. So that one's really important for things like when there are, for example, like bushfires at the moment, that all those particulates that are in the air from the bushfire is actually removed before the air goes into the lab. In cases where it's extreme disaster, you would generally want to actually turn off the fresh air intake. You want to be able to separate that fresh air intake, because no amount of filtering, if the air is thick with smoke and ash and particulates, there's not much an air filter system can actually do to be able to remove all those contaminants before it goes into your lab. So having a separate shut off for air intake in extreme circumstances is actually quite beneficial for a lab. So in terms of a lab, you want to have positive pressure within the lab. Generally, you want about plus 30 pascals. That's what you want in a lab. And then you have it what we call cascading. So the embryology lab generally will have the highest pressure, and then it will cascade into, say, an andrology lab or even an embryo transfer room. And then from there, it might transfer and cascade down to less pressure again to your normal spaces. So generally you would have, in an IVF lab, you'd have plus 30 pascals and then 15 plus 15 pascals in an andrology lab, or even an airlock. If you have an airlock into a lab, also the ET room would have a plus 15 as a general rule of thumb, and then to normal pressure once you're outside. The labs now that I'm doing generally will have an airlock. It just helps with opening and closing doors. So the more pressure you have differential between two spaces, you'll actually have a lot of trouble opening and closing doors. So the cascading effect, as well as pushing out the air, also helps with actually the operations of the rooms. Humidity, we'll generally try and look at 40 to 45%. That's actually quite high in terms of normal air conditioning. Normal air conditioning has generally a lot lower humidity, so it's something to be aware of. So when you have engineers that are helping you design, particularly sort of like the air conditioning system for lab, you just need to give them almost a little bit of education in terms of the particularities of an IVF lab, because it's quite different to, say, a pathology lab or a clean room lab. So they're much more common where engineers will be working on those types of labs. So to be able to educate the engineer in the requirements for an IVF lab is really important. A lot of engineers just assume that an IVF lab is the same as a clean room lab, which it isn't. So temperature IVF lab, we generally look around maybe 22 to 24 degrees Celsius. What we try to do in an IVF lab is not make it too cold, so that it's closer in temperature to what body temperature would be. A lot of times we get a lot of feedback from the hospital staff, because hospitals like their operating theatres to be freezing, 16, 18 degrees. They want it cold. And a lot of times for OPUs, for egg pickups, the scientists don't want it that cold. They actually want the operating theatre warmer. So there's always a bit of contention between hospital staff and scientists in terms of temperature. But in the lab, ideally, you want it a little bit warmer than what you would normally have. Air change. So it's really important to have air changes. So fresh air changes, 15 per hour, which is fairly high. So in your normal office environment, would only be about 3 or 4, maybe 5 air changes per hour. There's a fairly high air change for labs. So that's something to think about as well, and something to sort of let your engineer know as well, that you want a higher amount of air changes. The rust inhibitor in ductwork. So a lot of prefabricated ductwork, so they'll come onto site. So these are the steel ducts that are through here, the rigid ones, not the flexible ones, the rigid ones. A lot of times, particularly in countries where there is high humidity, So for example, here in Brisbane, we have fairly high humidity. It is generally normal practice for the contractors to put in rust inhibitors within the ductwork. What you want to stipulate very, very early on is that they do not put that in, as a lot of times the chemicals in rust inhibitors is actually embryotoxic. And because your air is blowing over the rust inhibitor, you will be pumping those chemicals into your space unknowingly. So something to really think about, particularly for those in countries where you do have high humidity, it is standard practice to put in rust inhibitors. So also in terms of air conditioning, so that's the sort of the more technical side of air conditioning. And I'm not a mechanical engineer, but over the years of doing this, I've learnt all basically the key elements of things to look out for when designing the lab. So I can actually check and help my client educate the engineers in terms of what we need to do for the air conditioning requirements for the lab, because it is quite specific for an IVF lab. So we look at, in Australia, the minimum room height has to be 2.4 metres. So every country will have different types of regulations. So that's the building regulation Australia. For any space that is occupied, it has to be 2.4 metres minimum requirement. There's some exceptions like storage cupboards and things like that, but generally any room that have people in it needs to be 2.4 metres. Now, in some cases, for a lab, that's all you can get. So I generally try and design labs that are 2.7 metres high. It's a good ceiling height. You can go higher, but the problem is the higher you go, the more volume of air you need to push within your lab. So that ends up increasing costs. And it also increases the size of the air conditioning system that you need to keep that air circulating. So 2.7 is a good height. And the reason why I try to aim for 2.7 is the image on the left, that's 2.7. The image on the right is another lab I've done, and that was 2.4. We're restricted to 2.4 for that lab on the right, simply because the space, the ceiling void that I was talking about before, within the ceiling was only about 500, 600 millimeters. So really very, very tight. We needed pretty much every millimeter we could get. So that ceiling space ended up getting pushed down to 2.4. Now, the problem can be with a lower ceiling space is you can get too much air movement in the lab. So to achieve the 30 plus 30 pascals of air generally requires quite a lot of airflow to push it through the registers. So it means you can actually get too much airflow, and depending on where you position those registers in the ceiling, you can end up with too much airflow over lab equipment or staff, either of which is not ideal, because too much airflow, as you know, dries out media if you're working on the benches, and it can get very, very uncomfortable if a staff is sitting under a register that's blowing a lot of air over them. So 2.7 just gives you that little bit more space for that air movement to not be as strong. So it dissipates a bit more. Having the different types of diffusers. So the lab on the left, basically the diffusers, which is where the air comes out of the vents, it's a stainless steel plate with perforated holes in it. So tiny little holes that are probably only about 5 millimeters, even sometimes less in diameter. So they're perforated mesh. So that's ideally in a lab, that's the type of register you want, because it pushes air through, but it doesn't push it through in such a strong direction. It actually dissipates within the lab. Whereas the one on the right, you can see it's a swirl diffuser, which is still better than your standard air conditioning diffusers that you'll get in most office buildings, but it will slow down the air significantly compared to normal diffusers, but it still does push a fair bit of air through. So just something to be aware of. Even the type of diffusers you use is quite important within a lab. So reiterating the fact that it's so important to get an experienced mechanical engineer when you're designing a lab, particularly for IVF, because then they will understand your requirements, and they'll actually do a really good job. So the one on the left where they've positioned the lights, where they've positioned the registers. So the registers, the air conditioning register that's blowing the air is actually in the middle of the walkway space. So it's not actually blowing on the benches. It's so you can do whatever you want. It gives you full flexibility for the benches. You can do, you can do ICSI, you can do, your sperm prep, you can do your egg prep on the benches without much worry, because you're not going to end up with a lot of air blowing over your work environment, and it's not going to blow air onto the staff either. So that's really important in terms of even just the layout of where the air conditioning registers go. So the next one, leading on from air conditioning, is air quality. So Keshav's already sort of mentioned the importance of air quality, particularly in a lab. One of the first things before we even get on to VOCs is to make sure that the space in the lab is sealed. So I've got an example here of a lab where we've had to have a column within the space. This one actually runs gases and power down this pole, inside of this pole. So you can see that they've cut the plaster ceiling, so it's solid plaster ceiling around the post, but they haven't sealed it. Make sure all joins between walls and ceilings are sealed, and you can use silicone for that. Silicone's quite good in terms of VOCs, because what's going to happen is ceiling spaces tend to be quite dusty. You can get vermin in there, you can get a lot of dust buildup. It means that those things will actually get pushed into the lab, which is what you want to avoid. Even things like light fittings. So you can see here, the light fitting actually should be sealed within the ceiling space. You can see here there's a bit of a gap between. You just run a bead of silicone around it. And now if you're using LED lighting as well, the advantage of it is it has a really long lifespan, so that you don't have to be pulling the lights out to change light bulbs as often, so you can actually seal these. So there's two areas that I see a lot of penetration for dust ingress and particulate ingress and contamination ingress. So make sure your labs are sealed spaces, and if they're not, run around with some silicone and seal those little spaces up. Okay, so we'll get on to VOC. So ideally, and this is ideal, and it's very hard to achieve in most instances, but I have managed to achieve it in pretty much all my labs, is that you want less than 500 parts per billion for VOCs within the lab space. And to achieve that, the best way to achieve it is in terms of materials. So if you can reduce materials within the lab, building materials that is, within the lab that do not emit as much VOC, that will really help you in terms of keeping those VOC numbers as low as possible. So things like MDF, which is a medium density fiber board, so they have a lot of glues within them. It's quite a common construction material. And because of the glues in it, it's constantly off-gassing, and it will constantly off-gas for pretty much the life of the material. Another material that's not great, mainly due to the glues, is plywood. So plywood, again, something to avoid in an IVF lab, simply because the glues in it will continue to off-gas. The other thing is laminates and melamine. It's quite common for, say, kitchen cupboards, etc., to have laminate or melamine in them. Try to avoid them simply because the fibers between are very similar to the medium density fiber board. So the fibers in there, and it's all just glued together again, so they will continue to off-gas. It gets used in kitchens because it's moisture resistance, but the moisture resistance comes from the glues that they use, so which is not great for VOCs. What you can use is compact laminate. So it's different to normal laminate. Compact laminate, the process involved, it still has glue, but it's actually compressed and heated at a very high pressure. It's a really solid material. And generally it is a lot thinner than your normal laminate or melamine. That's how you can tell the difference. And generally it has this black core, whereas your melamine and laminate, if you cut it, it'll just be timber fiber core, like you can see there, whereas the compact laminate will have a black core. Some countries, like in the States, it's called Trespa. So that's a good product to use, particularly for lab bench tops, because it's not very thick and it can span by itself as a bench top. So it's quite good for that. Stainless steel and aluminium, no VOCs for those. Use those where you can. In Australia, stainless steel is really quite expensive, so we end up using a lot of times compact laminate, as it's a cheaper alternative to stainless steel. Stainless steel, and you can use aluminium legs within your benches. That's also really, that's fine. There's no VOC issues with there. Just got to watch with stainless steel, because it's actually quite thin. Normally it needs a substrate, so something underneath to support the stainless steel top, to give it rigidity so it's not flexing. A lot of times in Australia in particular, they will use plywood underneath the stainless steel to stiffen it up. Got to make sure that they don't use that. What you can do is actually build a frame, so a aluminium frame underneath the stainless steels to support the stainless steel span. So you can just have basically bracing and cross members underneath within the bench framing, and then the stainless steel can sit on that without sort of any rigidity issues. Now these three down the end: adhesive, sealants, and paint. So really in construction, you can't not use those three items within a lab. You need them. So adhesive, so for putting your vinyl on the floor and on the wall, you need adhesive. There's no real way around not using these products. So my advice to you is to test them. So do research, and I have a list, well, for products available in Australia, I have a list of products that are low VOC. And a lot of times, even though a lot of products say they're low VOCs, particularly paint, they're all sort of heading towards low VOC now, but not all low VOC paints are still suitable for a lab. So when generally products are saying they're low VOC, that's low VOC for humans, so fully grown humans. It's not suitable for an embryo or gametes. The threshold for low VOC well exceeds what we would find acceptable in an IVF lab. So it's something you need to test, and generally a lot of those things, adhesive, the sealants, the paint, will off-gas over time. The VOC levels generally will reduce over time, but it's making sure that you have that time to off-gas, because once you push that positive, when you seal up the lab, put that positive pressure in, there's actually not much you can do in terms of burning in the lab to reduce the VOC. So if you can start off with low VOC materials from the start, it'll reduce your off-gassing time. It'll reduce your burn-in time. You can get your lab up and running sooner. So that's the main advantage of that. And, bring out your trusty VOC meters and test the materials. So generally we will test, we'll do up prototypes. So we'll have a prototype of floor vinyl with adhesive, and we'll test that to make sure it gets to a point where the VOC levels are acceptable, because for the level that you're aiming at, that 500 parts per billion, it's for the whole lab, not necessarily just for that one material. And you can get adhesives that are, they're astronomical. And you can smell it. So as soon as you can smell it, you know that it's well above what you would want in there. The other thing with air quality is, particularly for countries that can't afford to have labs that have the whole room sort of air conditioning systems at best practice, you can use things like Coda towers within the spaces, and also cribs. So the IVF cribs now, they're humidity controlled, they're temperature controlled, they have HEPA filters that go into the crib as an alternative to making sure that the whole room complies. Making sure that you do your critical work within cribs is it's actually a cheaper alternative than trying to do the whole lab space. So something to consider for, still getting best practice results, but without the expense of basically, air conditioning a whole lab space to critical standards. So clean room standards, a lot of people think we need to have clean room standards. We're moving towards clean room standards, but there's still a lot of difference between IVF labs and clean rooms. We're moving closer and closer. The designs are moving closer and closer to clean room standards, but we're not quite there yet. Generally, if we try to keep it at the same level as operating theatres, generally at the moment, that's considered acceptable. So with those exceptions about temperature and humidity, generally we'll aim to have, it's the same level as operating theatres. But again, we've got the extra VOC requirements. So another thing to think about is the building structure. Anti-vibration design, something to really think about, particularly given the highly intricate work that embryologists do. If you are lucky enough to be able to build a new building and not move into an existing building, make sure that the structure has enough reinforcements in place, particularly if it's concrete slab and it's a multi-level building, that has enough steel reinforcement in to reduce vibration within the slab. Generally, you haven't got much control over that, so anti-vibration tables or anti-vibration platforms would be required. So this is an image of a building that one of my labs went into, and because it was a dedicated hospital and medical centre building, they actually put a lot of steel. You can see there's a lot of steel within the concrete slab before they poured it. It just gives it a lot more rigidity and also strength, because we've designed this to take LN2 tanks as well. So which goes to my next point, which is about LN2 storage. So really think about the weight of LN2 storage tanks. And as the world is moving towards more and more LN2 storage requirements, particularly as now we've got, elective, in Australia, we've got elective egg freezing is becoming more and more popular. We're storing more and more materials for longer periods of time. So tanks, the requirement for tanks is just going to increase over time. And particularly if your lab grows, the more cycles you do, the more you're going to have in terms of storage for LN2 tanks. Got to consider the extra weight of the tanks. A lot of times you might not have any control about the structure. That's generally the case. If you don't, generally the rule of thumb is around columns within your building is where most of the structure is. So if you can put your tank room near a column or very, very close to a column, ideally, you'll end up with more strength in those areas. So they'll be able to take the extra weight of the tanks more so than if you're in the middle of a slab and the columns are quite far away from where you put your tank room. So something just to note, when you're looking at putting in a new lab or refurbishing a lab, where to put your LN2 storage tank room. Another thing is floor protection for LN2 tanks. A lot of times we try to put flooring in to protect basically the concrete underneath. Concrete really doesn't like thermal shock, which is usually happens when your liquid nitrogen accidentally pours onto concrete. It will crack. And if it does it often enough, it'll start affecting the integrity of the concrete slab. So something you want to protect the floor from where you can. So a lot of my labs, I'll try and use aluminium or stainless steel plates, as you can see in that image there. So the tank room has aluminium and stainless steel plates. The advantage of it is it doesn't crack. It will move, it will shift a bit, but then it'll just go back into place. Rubber is another alternative. It's a good insulator. The only problem with rubber is some products, some rubber flooring products have fairly high VOCs, so something to be aware of. There are low VOC rubber products, but generally you'd have to off-gas it a very long time before you get to an acceptable level. The advantage of it is that you can replace it. So a lot of times the rubber flooring is in tile form, so you could actually take it out and replace it if it cracks. Vinyl floors, really common in Australia. Most tank rooms have vinyl floors because it's cheap. It is prone to cracking and it needs replacement. What I generally do, if that's the case, what we normally do is we will actually have maybe a different color area of vinyl. So where you do your decanting of the liquid nitrogen, where spill is more likely than not, we'll actually do a separate color vinyl. So everyone knows that's the place where you decant. And then so when that piece of vinyl cracks, you can just replace that piece of vinyl. You don't have to replace the whole floor. I've seen a lot of tank rooms where it just has concrete. It is prone to cracking, just something to be aware of, because the cracks in the concrete actually creates dust naturally. So if it's starting to crack, you'll actually get particulates within your tank room. So something to be aware of. Gases. So you need gases in your IVF labs. To have a secure store with easy access to a loading bay is important, because you can then get really efficient swapping out of your gas bottles, and make sure your gas room allows for growth. So you have enough manifolds, or you can easily add manifolds. Generally, most of the bigger lab gas stores are separate from the lab, and I would encourage that to be the case, simply because of deliveries. You don't want that delivery people coming into your lab space. If you're in a multi-story building, a separate lift access for liquid nitrogen delivery, but in particular due to the displacement of oxygen if there is a liquid nitrogen spill. So a lot of times either it's a dedicated goods lift that only carries goods, or you have a key override, so it goes directly from the basement, from delivery straight up to the lab space, and no one can enter the actual lift unknowingly. The use of stainless steel pipework for your gases, that's what we're trying to aim to do. And again, it's something you should let your engineers know. Otherwise, they'll end up using copper pipes, which isn't as good. We've got some issues with that. Alarms. So make sure your gas rooms where you've got your LN2 store, and even your normal gas rooms, has alarms, so both audible and visible, so that it's making a noise as a light, so that people are aware on the outside of the room before they walk into the room that there's been a gas leak. So a low CO2, a high CO2, and a low O2 monitor. So with the gases, the alarm, the actual sensors for the low oxygen should be around about sort of 1.2 meters to 1.5 meters in height. So that's where those sensors should be, because if it's low oxygen, and that's basically the level of most people's heads. The CO2, the high CO2, because CO2 is a heavier gas, generally that sensor will be about sort of 300 millimeters off the floor, so it's much lower. So if there's a buildup of CO2, then you know that there's a problem there. So, and then the other thing is to also check your gas gauges are suitable for the equipment, particularly in the lab. We've had some issues recently where the gas gauges, the measurement of the gas, the amount of gas that's coming through, was a lot higher than what was required for the equipment. So it meant that you couldn't actually get a proper gauge of how much gas was going into the equipment. So something to be aware of. So power, absolutely critical in an IVF lab. UPS and backup power. So UPS in an IVF lab Most of the equipment requires it simply because it takes out the peaks and dips of power where it's not as reliable, but also for backup. So really important. A lot of times for UPS backup, and this is where you kind of need to educate your electrical engineer as well, is the requirement for backup. So really the time you need to back up with a UPS is really disaster management. In general, most electrical engineers think of UPSs as connected to computers. So generally the UPS only lasts for a few minutes, maybe 10, 15 minutes max. Not, as you know, it's not the case with IVF labs because we have to run our incubators 24/7. They can't stop. And a lot of engineers will try to probably talk you into reducing the time of the UPS simply because they'll say that the backup generator will kick in. There's been several cases in Australia where the backup generator was the hospital backup generator that was connected to the lab, and the generator did not work. So there was pretty much quite significant losses in the IVF lab because the UPS was not designed for, to take basically what should have been the backup generator kicking in. So the time for the UPS wasn't enough. Generally, as a rule of thumb, I would suggest as an absolute minimum for a UPS power requirement is nothing less than 4 hours. I have had clients that have wanted less simply because of the cost of the UPS, but the cost of losing embryos is a lot more than what it is for the cost of installing a UPS. Minimum, I would say 4 hours. For the larger facilities, we do 10 to 12 hours. So basically, worst case scenario, something happens overnight, the UPS will keep running until the morning when the scientists come back in. And I have had ones, very, very big labs where they've wanted almost 24-hour UPSs. So the UPS ends up being massive. So the two images down the bottom here, they're both UPS rooms. The UPSs are massive. In Australia, it triggers fire rating requirements because UPSs can catch on fire, which means we've got to put it into a fire rated room. The other thing with UPSs to know is that they need to be air conditioned because they do heat up. So there's extra costs in running a air conditioning system to keep the UPSs cool. With the generator and the UPS, regular maintenance and testing is absolutely critical. So make sure you've got a regular testing regime for both the UPS and the generator to make sure that the generator kicks in when it's supposed to. The stories that have happened in recent years in Australia, and we don't get many sort of blackouts at all, where the generator has not kicked in, has been quite devastating for the labs. So, and also too with the generator, make sure that you have an agreement in place for fuel supply, because once the generator gets going, and if it's a prolonged period where there's without power, you'll need to top up the generator. Make sure that you've got a non-fuel supply to be able to keep that generator running. So within the lab, power for the equipment. So allow enough points for flexibility and expansion. So here are a few different labs I've done over the years in terms of power and how we look at putting in PowerPoints. So a lot of times I'll actually use what are called ducted PowerPoints. So the duct runs along the wall. This allows, and you can see with these ones, I've actually got blank plates on them. So basically the cable runs within that duct. If we need to add extra cable, extra points, whether it's a data point or a PowerPoint, it's easy enough to run through that duct without any disruption at all to the lab. So we don't make a big mess. We don't need to cut holes in the wall. I don't need to do anything other than really take that plate off, run the wire through, put the new plate on with the either power or data points, and then we're off. So if you can have a system that minimizes disruption to the lab, it's ideal. Or you can do what I've done in this other lab, is that we've actually put in like so many extra PowerPoints. So as a general rule of thumb, you would probably put in 2 to 3 times what you actually think you're going to need. So you would count your equipment now, what equipment, what data points, what PowerPoints they need, put in basically, if you can, double to 3 times more, because as technology changes, you will use more. So it's not just power, but don't forget to put data as well, because there's a lot of monitoring with the equipment that's required now. So you'll need data points as well. As you can see, I've got lots of spare points in this one here in particular that's ready to go for future equipment that's going in. Which leads us on to flexibility and expansion. So the general lifespan of an IVF lab is 10 to 15 years before it becomes a bit too tired and probably obsolete in terms of technology's moved on. I'm sure you've all worked in labs that have had a lifespan of much longer than 10 to 15 years. But if you're doing something sort of that's now, if you're looking at building a new lab or expanding a new lab, generally you'll be looking at a 10 to 15 year lifespan. So if it's well designed, your lab should need absolutely minimal refurbishment during that 10 to 15 years. And if you've done all these things that we've talked about, future proofing and planning and, allowing for growth, generally your 10 to 15 years you should be able to do basically nothing to the lab until the end of that 10 or 15 years. So definitely consider expansion. So, and not just a little bit. A lot of times I'll actually question IVF units if they say, oh, at the moment we're currently doing 500 cycles, we'll look to expand to 750. A lot of times, once you put in the new facilities, people will generally come, and that's with all new facilities. Most facilities will grow a lot more than what you kind of think, and a lot of times it's because the existing lab can't grow because it's actually hampered by the space that you're limited in. So a lot of times I'll say to people, look, if you're 500 now, let's allow for, say, 1,000 or even sort of 1,250, just so you've got that future proofing, because it will grow. Like, I don't know, in 15 years I've been doing IVF labs, they've all grown. Every single one has grown, and they've grown a lot faster than what they had predicted, simply because their existing facilities was hampered and it was actually restricting their growth. So please allow for them. I'm showing you now. So this is 3 labs that I've done within the last 2 years. And every single one of them I've allowed for future growth. So basically in this top right-hand corner, that lab has room for basically another 750 to 1,000 cycles. This lab in the middle here, that has growth to pretty much double. This lab was actually designed for 5,000 cycles. They are currently doing about 2,500. So we've got enough space here to basically double their capacity. This little lab on the bottom right-hand corner, brand new facility, didn't exist before. We've designed it straight up to do about 1,500 cycles. It will take them time to get there, but it'll allow for that. The extra space we've allowed for, which was originally for extra incubators, they're looking at doing PGT because they've got space to do it now. So they can add extra services for the patients as a result of the growth. The other thing to allow for is also allow for extra power and gas for new equipment, because equipment is constantly evolving. to make sure you've allowed for that. You know, at the moment, a lot of labs, particularly in Australia, is moving away from the triple mix gas simply because it's so expensive. So a lot of the equipment now, they're moving only solely to nitrogen and CO2. So allow for that change in equipment, and allow for a change in workflow, particularly now with AI coming in, and different equipment, even time lapse to an extent in the previous few years. A change in workflow is actually something to allow for, and to be able to have, and you can see in all my labs, the benches, they can move around. So we can actually move those benches around to either remove it or shift it to a different location so that we can actually put in different types of equipment. But the big one, I think, coming up that's going to be a proper issue that needs to be looked at, I think, collectively, is cryo storage. Tanks are sort of growing. A lot of the big facilities that I've worked on, they're basically, you know, several new tanks a month. And it's something that we really need to be thinking about, how to store tanks better, and safely. So, you know, and not, you know, increase risk to patient in case there's a failure within the tanks. Staff workflow, really important. So workflow in the space required, you know, having clear walkways for safety, not only for the staff, but also for, you know, accident prevention, disaster management, those sort of things. In Australia, we have to have a minimum clear walkway space, doesn't matter what type of facility it is, at least 1 metre, and that's for fire egress. So we cannot have any paths of travel within any facility that is less than 1 metre in width, so that people can exit safely. And all of our building code compliances means that, depending on the type of building and the amount of exits there are, you're not more than 20 or 40 metres away from an exit. So those designated paths are always kept clear. There's no equipment in the way. There can't be any furniture in the way. It's a clear path for safety access. And in a lab, I mean, that's really important, particularly in so disaster management situations where people are moving around quickly. So 2 labs. The one on the left is a baby lab, 60 square meters. It has about 1.3 meters between the benches. So between the ICSI rigs and the bench that has the time-lapse incubators, there's about 1.3, 1.4 meters. It allows for people to work at the benches and people to still stand and observe what they need to do in terms of the incubators, without any collisions. But it is tight enough so that we're not having, you know, a lot of space. Whereas the lab on the right that I have, it's got about 2.2 meters. And that's simply because we have people working on both sides, and also the thoroughfare within the lab is between the benches. So with the amount of movements, because this is a fairly large lab that generally has a lot of people, with the amount of movements, we've made that walkway wider just to reduce accidents. Another thing to consider is visibility and communication. So, for example, we've got data entry staff, so scientists doing data entry and even patient consults in the lab that's outside of the embryology lab. So the embryology lab's on the right in that window, the andrology lab's on the left there. It means staff can communicate without compromising air quality, and they can also communicate with each other. Just makes the collegiate atmosphere of the lab a lot more profitable as well, in terms of, you know, people be able to collaborate within the lab. So we generally try and within the lab have really good visibility within the lab. And then in the case of, say, we've got on the right here, andrology lab, we've got a airlock, a little hatch that goes into the embryology lab. So things like that means that it saves people time, that they don't have to carry sperm into the embryology lab, they can actually just pass it through the wall. So we use a lot of pass-throughs within the labs, and also maintain pressure within the lab space. And then we'll have a little intercom to talk between the lab. So there's a little intercom there next to the hatch. The other thing to think about is bench heights. Ideally, I mean, in an ideal world, you'd have the adjustable height benches where you can just move them up and down. They can be quite costly, and in the case of being able to put equipment on, they're not generally strong enough to be able to put equipment on. So generally you'll have 3 different types of benches. One's for sitting at, generally that's about 750 millimeters high. A standing bench, which is generally about 900 millimeters high, and then one for equipment. So it really depends on whether the equipment is a tall piece of equipment or you're trying to fit equipment underneath a bench. That will vary. So you can, have benches that might be 1.2 meters high because you need to fit an incubator underneath the bench, or you might have a bench that is 650 millimeter height because you've got an incubator above a bench and you want to be able to access it. So it'll just depend. Staff wellbeing. This has become a really big issue, particularly in Australia, where we're finding there's a fairly high turnover of embryologists because of burnout, basically. So if you can provide external outlook for the staff, that's really good. A lot of my labs have been lucky. A lot of my labs have had really good external outlook. As such, we have had to do a lot in terms of making sure that the windows, either the glass itself, or we've had to put film on that actually mitigates UV and also different wavelengths of light that aren't that are detrimental to embryos. So we've had, so all of these, either it's built into the glass, so we either use low E glass that reduces heat load, it reduces UV light directly within the glass, and it just depends on the facility. And if they don't have it in older facilities, we'll put film on to reduce that. And then breakout spaces as well. So we, to be able to have a really nice breakout space for staff is really important for their well-being. And again, the advantages are that, you retain staff, you retain their knowledge, they can help you grow the business, they can train up younger, new members of staff. You've got a knowledge base there that's going to be kept within the IVF facility. So thanks for that. I know it's went a little bit over time, but yeah.
Thank you. That was a fantastic lecture. There's so many things that I myself learned from your lecture, Charmaine. We have a couple of questions. Maybe we can answer that before we move on to the next
Yeah,
one.
sure.
So I think someone's asking about paneling for portioning of the IVF laboratory, whether aluminum panels is something that is recommended. What are the other different options? You can briefly speak upon that.
Yes. So aluminium panels, yes, absolutely. Just make sure with the aluminium paneling that your services are pre-cut in and that you allow for expansion, because once you've cut, like for refurbishment work, once you've cut into the aluminium panel, to patch over it, you either have to completely cover it. It's not as simple to fix up if there's been a mistake that's made. But yeah, absolutely, aluminium panel is a really good option. It's quite expensive though, so that's the trade-off. That's the trade-off.
And are there any other options which would be cheaper?
Yeah, so in Australia, drywall plasterboard is a really cheap material.
Okay.
And it's quick to put up, it's cheap, and generally we will cover that with vinyl, so a vinyl, wall vinyl, just to give it a bit more robustness, because it's actually quite a soft material, so equipment moving around will actually damage it. So we'll use that. It's quite economical in Australia. I would say that's probably quite economical in most places. The vinyl protects it, so you're not really going to have any issues in terms of robustness for that one.
I think the next one that you already answered, which was on the glass windows. And Some of us are worried about UV light penetration.
Yes, yes, yes. Generally, yes, most people are, but to make sure that you've got the right UV coating within the glass and film can negate most of that.
And it makes a huge difference because looking at those laboratories, I was like, I really want to work here.
Yeah, exactly. The other thing we can do, and I've done it on one of them that you couldn't really see, is that we've had external blinds. So we've had blinds rather than in the lab, because you don't want fabric within the lab for contamination purposes, and have external blinds on the outside of the building that you can actually adjust as well.
Yeah.
So that take out a lot of that as well. So that's another option.
The next one is about lighting within the laboratory itself.
Yes.
Is there
Yep.
something that you recommend?
Yeah, so generally within a lab, I would say use light that is on the warmer spectrum. So there's a light color chart. So 3000 Kelvin is a little bit warmer, not too warm, so you feel like you're going to fall asleep, but it's not the white light that you'll get in offices. So 3000 Kelvin is a good light color.
Okay. And if the lab is not modular and does not have like a central HVAC, how does one manage? Does a regular filter work like those Coda towers?
Yeah, so coated towers will work to an extent, and it really depends on the size of your lab. So really, like if it's a small lab, a couple of big coated towers would be able to, you'd be able to get away with it. It's when you get the really big labs that coated towers, you're just not gonna, you'll end up with more coated towers than equipment to be able to um, make sure the air quality is of a high standard. So if it's a small lab, you could probably use coated towers. Still, you would be trying to, implement some sort of at least a HEPA filter if you can.
Yeah. And the last two questions, then we'll move to the next presentation. Venkatesh is asking walls for the walls. What should one consider? Concrete or gypsum for the sterile area, OTs, etc. What can be done for the semi-sterile area like the andrology?
Semi-sterile areas, you could use gypsum. You could still use gypsum for the walls, for the semi-sterile, even the sterile areas, as long as as long as they don't get damaged. So like I was saying, if you put a vinyl over the top, it'll just give that extra bit of robustness. It's not a problem. I mean, you're not doing anything in those labs generally that would damage walls anyway. It's just the moving of equipment, or even a LN2 tank that's moving around. That's generally the only thing that would damage a wall. So you can use gypsum, that's not a problem.
Yeah. But you were telling me, like in your presentation, especially with concrete, when it breaks and when there's dust around it.
Yes, yes. So concrete generally will be in the floor. If it's in the walls, same thing, it needs to be sealed. So any concrete surface, if it's bare concrete, you need to seal it, because if you don't seal it, concrete naturally will give off dust. So you'll find that if you just have a look at spaces that just have a concrete floor that hasn't been sealed, you'll actually, after walking along it, you'll actually pick up like a white dust on your shoes. And that's because concrete will actually naturally give off dust. You need to make sure it's sealed. Yep.
Okay. And last one for you, can you talk to us a little bit about certain regulatory requirements for Australia, uh, which you tend to follow?
So in Australia, interestingly enough, there for an IVF lab facility, there's no strict requirements for an IVF lab. So we're using a lot of the research that's come out from either ESHRA or from alpha scientists. We're using that as the basis of improving the air quality, particularly within the labs and the design of the labs. In Australia, the only real thing we have to comply with is our National Construction Code, which has to do with safety of patients in terms of fire egress, safety of staff in terms of fire egress. So that's probably the essence of what we need to comply with in terms of the base building requirements. But the other regulatory requirements, there actually isn't a there's an international standard. So the International Health Facility Guidelines has guidelines about IVF labs as well. But again, none of that is really mandatory. And a lot of times our health departments now, only in the last 12 months, a lot of the health departments will want to have a look at the labs to make sure that they're up to a standard, but they're not really sure about what the requirements are either. So it's still a work in progress, that one.
Yeah. I'll pick your brain now with certain images, Charmaine. I have a comparative image here where on one side, on the left side, you can see that the HVAC is probably going to get installed into the ceiling itself.
Yep.
And on the other side, you have this vent that goes through the laboratory and the OT because this is probably something that they did later on.
Yep.
Uh,
Yep. Yes.
what would your thoughts be on the one on the
Ideally, I think the one on the left is much better. It's nice and it's going to be a nice sealed space. So
yeah.
once he's finished sealing up all those corners that he's got in there, it's going to be a really nice sealed space. You can control your air pressure, you can control your contaminants.
Yeah.
It's that to me is going to look like to be a really good space. The space on the one on the right, we'll have issues in terms of dust collection, like in all labs, regardless if it's IVF or not, we try to minimize any areas where you can have dust collection. So even though we've got really good air going through, you will still get dust within an IVF lab. And that to me, that's like above where the register is. No one's ever going to get up there to clean it. Like it's just,
And there'll just be dust all over,
yes, yep, that's right.
which can end up firstly reducing your fertilization, blastulation rates, also increase
Correct.
contamination, all of that.
Yes, so it's contamination. It's a source of contamination which we need to avoid. Yep.
This is a nice study that I found from Jason Swain where they compared before air filter and post air filtration, their outcomes, and you can see the nice jump in blastocyst conversion rates, implantation rates, clinical pregnancy rates, ongoing pregnancy rates, and also reduction in the miscarriage rates. And this is something that really tells us that filtration and air quality is of utmost importance within the laboratory. This is
Yep.
from Jack Cohen's group, and this talks about um, a decrease in these clinical pregnancy rates and implantation rates. And you can see that the first decrease happened during the fumigation itself of the periphery, not the laboratory itself. And you saw that it went almost half of what it was originally. And then the second one also happened um, here. And then this was probably because of not changing the air filters, and then once the air filter was changed, they got back to their current standards. And these things need to be thought about. This,
Yes, yes, absolutely. Maintenance is really important for air filters. You can't just leave them in and hope that you don't never need to change them. So location of air filters is really important. You want to ideally not have them within the lab. You want to try and have them outside the lab so you don't have work people coming in to change filters within your lab, ideally. So
this
that's
is
something to think about as well. Yeah.
this is a horrifying image for me, man. These are photos from within the vents of the HVAC, and look at how bad they get. Look at the amount of gunk that actually gets accumulated if you don't maintain them on a regular basis. This is a nice clean one, but all
Yes.
of the others are like terrible.
Yep. Yep. And that comes to filters as well. So if the filters are not cleaned regularly and replaced regularly, that's what happens.
Yeah. I have a couple of more images now. This basically talks about the workflow. If it feels like a maze, it becomes very difficult for all of us. And I think you highlighted it quite well, especially when we see a laboratory like this where there's not enough space for movement. If someone's working at a workstation or standing here at the centrifuge, it really obstructs workflow, and it really like frustrates the embryologists because they're carrying dishes. They want to like reduce exposure. So it's of utmost importance that we plan the laboratory well. These things, like a cylinder within the laboratory, something that we would want to avoid for ergonomic purposes. Having better stools, uh, Countertops, especially if there's high vibration within the building itself, you'd want to invest in something better for
Yep.
countertops, especially for ICSI. Um,
Yes.
this is my laboratory. I still need to work on my floor, but this is where I've been working for the last 14 years now. And what we've incorporated now is an alarm system for the laboratory, which looks after the environment for the lab. And this is an Indian-made alarm system called Lab Health. And this is something if all of you are interested in, you can think about. It really gives me an overview of how the environment for my lab is. Um, and it gives me a lot of safe, like my head is in the right place.
Yep.
There are some new labs that I just visited last year. What I really liked about this one was that all of these panels can actually be modified and you can actually put it as you would like it. And this whole
Yes.
lab installation took about 2 weeks for
Yep.
all of these panels to be put in. So that was fantastic. This one was in Korea, and so this is between two laboratories. And what I actually like, what you if you can make out, all of the backs of the incubators are within this room,
Yep.
and all of the gas supply regulators, etc. Everything's within this room. So you just need to enter this room to change the filters, do whatever you want. All the service and maintenance happens here. And this is connected to two different laboratories within the same unit.
Yeah. But that's really good because it means people servicing it don't need to enter the lab at all. So that's really good.
It was a fantastic experience visiting. This is Cha Hospital in Korea. All right. So with this, Charmaine, I think you have another presentation uh, which talks about the modern emerging trends in architecture. And post that, we can keep that as a short, brief presentation because we already run
Yes.
a lot of time.
Yep.
And post that, we can have some more questions and we can end the session.
So, modernizing sort of emerging trends in IVF labs. Probably one of the ones is patient experience is probably the one that's the biggest emerging trend at the moment. People are expecting IVF to be more like almost like a status symbol rather than something um, that's a necessity. So it's moving towards having more sort of patient-centered design. So we need to really think about that. So a few emerging trends. So patient-centered design, which has been around for a while, but it's really ramping up at the moment. A visible process for the patients, equipment, AI, sustainability, and costs. So I'll just go into the patient-centered design. So we want to try and create spaces that improve the patient experience in the clinic and also when, you know, for example, the ET room. So as you know, IVF is quite a stressful and emotional process for patients, for their families. And it's really important that we design spaces that actually support them. So by providing, you know, empathy, privacy, in some cases, distraction, a calming environment. So as an example, so the ET room that I've got in through here has nice views outside. The patient, for privacy, we've got external blinds that drop down so no one can see in, and then they can get changed, and then they go and have their embryo transfer. So things like having, you know, comfortable furniture, relaxing music, some warm colors, creating more of a home environment so it's not so clinical. Having distractions like if they can see outside or if there's plants or gardens, water feature or artwork, or providing information in strategic places as a way of distracting patients. That all helps in terms of creating a sort of de-stressing what they're going through, so a more welcoming environment. So as you can see, it's clinic I've done over in Perth, Western Australia. we've tried to achieve that. It's a really warm, welcoming clinic. The embryo transfer room is, again, follows through with that, just so the patients have a better overall experience. And it's also important because patient perception of your skills is all this front end area. If you present a really warm, welcoming environment, the patients have much more confidence in all the things that you do behind the scenes in the lab. So some just other images of areas. We've done patient-centered design. So this is as a recovery area after egg pickup, where patients sit down and they can, you know, have views of the park that's below. And same with waiting areas for families when they're waiting, they can, you know, they've got views outside to the city, and even consult rooms where the doctors are speaking to the patients. They've got, you know, lovely views to distract them. Also too, patient privacy is really important. So visual privacy for patients and acoustic privacy, making sure that, you know, in particularly say the men's collection room, that you've got really good acoustic privacy in there, just for the men, and also visual privacy so that, you know, they can do what they need to do without, you know, feeling uncomfortable. Lighting, so yeah, dimmable lights, and again, sort of, you can see in these spaces we have lights that are on the more yellow spectrum, just to take away that clinical feel. And providing information, so patient apps are really good because you can personalize information for that patient. And don't forget things like transport and parking, you know, public transport, access to public transport, who's picking them up, particularly after an egg pickup, if they've been under sedation, that they've got, you know, someone to pick them up that can easily pick them up, park the car, or, you know, easy access to public transport. So to go on from that, we have a look at sort of the visible process. So this is one area where we're trying to move to be able to break down those barriers for patients, so that they can actually see a little bit of the behind the scenes of the lab processes. So a lot of the labs that we do now, where, you know, the patients can actually either see into the lab or see into the tank room, where they feel a little bit more sort of connected to the process rather than being disengaged. And even with the embryo transfer room here, you know, they can actually see into the lab as well. And we've got a sliding door through there, but, you know, when the scientists are moving in and out, they can actually see into the lab as well. It's a way of connecting the patients to, you know, what embryologists do every day. It just gives them a sense of connection to the process rather than being disengaged. So AI and equipment, so really big. So allow enough space for new equipment, allow enough space for more equipment, power for the equipment, gas for the equipment. Make sure you've got sufficient backup power and space for more gas bottles. Make sure you've got enough IT and data infrastructure for monitoring of more equipment. So, you know, at the moment, automated cryo storage, such as Tomorrow, you know, it's a system that's starting to grow in this being used. I don't know if it's actually going to solve the amount of storage, because it can't actually store as much as, you know, some of the existing cryo storage facilities that we have at the moment. You know, to be able to expand, so for example, the case systems, the stacking incubators, you can use those to basically, within the same footprint, significantly increase the amount of incubators that you've got. Using your IVF cribs, there's more and more functions being able to be done within the IVF cribs. So it's going to end up being, you know, a really critical piece of equipment for a lot of labs. And then you've got Coda air towers, you know, obviously different sizes, and you can put them around the lab as a supplement for the air handling that's required, you know. And it might be that you need extra if you're off-gassing something, or if there's some external factors such as bushfires or something like that, that you need extra Coda towers. Sustainability. This is a really big area. So think of using sort of steam sterilization where you can. So there's fewer sort of harmful chemicals, and you can maximize energy efficiency using steam rather than chemical sterilization. Packaging, there's a lot of consumables in IVF. If you have disposable pipettes and dishes and things like that. Think about recycling the packaging, using less packaging, or going to using companies that either take back their packaging or have less packaging for delivery. Got a couple of websites there. For power usage, think about changing to all electric, because then you can use solar as a source of power, which is really the way to go in terms of minimizing using fossil fuels. Try to remove gas where you can. So as a fossil fuel, it's non-renewable resources, so you can use that. With lighting, use LED lighting, as there's a lot less energy required for LED lights, and also too the lifespan of LED lighting is much longer. You can get 10 years out of LED lights now, so you don't need to really replace it during the life of the lab. Try to use local suppliers where you can to reduce transport emissions. So, your deliveries, I mean, that the transport emissions is actually quite huge. So if you can, use local suppliers, and then think of using sort of biodegradable consumables. So, dishes where you can, not so much for within the lab, but even sort of, for ET and things like that, where you're using a lot of blueies, the mats that go underneath patients, that you can get biodegradable ones. So think of using things like that. There's also places that recycle healthcare plastics, and also PVC plastics, which generally isn't recycled. So, and recycling sterilization wraps. So there's all these things that are in place at the moment that are starting to grow, because it's major hospitals have done audits on the amount of waste that goes into healthcare, and it's one of the largest generators of packaging waste as an industry. So these things all help to minimize it. So to cost all these things, there's costs in terms of building new facilities. So funding is really important, and think about the life cycle costs. So when you're talking to whoever's funding the labs and the hospitals, think about it over the terms of 10 to 15 years, because your lab, that's the life of your lab. It's the investment, the capital investment is usually, quite large, but if you spread it out over 10 to 15 years, for a lot of financiers, it's a much more palatable equation. So something worth thinking about there. So capital costs, installation, the building, major infrastructure is a really costly expense when you set it up. But once you get going, the operating costs can take over. So, allow for things like, how much space do you actually need? Because the bigger the building area, the more it's going to cost you to fit out that space. Same with equipment purchase, that's got to be factored in, because if you're making a new facility, that initial purchase of equipment is actually quite costly. So operating costs, it can actually overtake the capital costs in 3 years if you're not sort of savvy about how you use and how to minimize maintenance costs. So you've got ongoing maintenance costs with the air conditioning, changing filters. You have generator maintenance costs, UPS maintenance costs, your gas costs that are ongoing, and your equipment maintenance costs. Think about those costs, because they're consumables. You'll need them, and that's an ongoing cost. So if you can reduce, your energy costs by using solar, that's actually a really big plus. So consumable costs, see what you can do in terms of reducing consumables. Maybe have a really good inventory system. I know there's heaps of labs I've been into where they don't even realize how much inventory they actually have within the lab. So streamline that. So, you order as you need rather than having stockpiles, boxes everywhere of consumables. Staff costs, obviously, to pay for your staff, to embryologists and your admin staff and doctors and everyone. and then your operating costs of rent, and then finance costs to finance these things. So things to think about and to frame your conversation if you are looking to upgrade, to how to get that financing across the line, because if you can't finance it, it's all these things that we want to do actually don't actually happen. So just a quick one there. That's really quite a quick look at things that are coming up.
Awesome. I think really like the way that the embryo transfer rooms were actually being planned, because I think that's one place where you would want the patient to be as relaxed as possible, because it's the culmination of an IVF cycle. And again, if the patient's not comfortable, if they're too tight with their bodies, it gets difficult for the consultant to really ensure a smooth transfer. And I absolutely love how the transfer room is planned with it overlooking the nice, beautiful park that's down below.
Yep.
Um, I mean, honestly, it would be a very nice place to work at, and I'm sure the patients would also enjoy such kind of comforts.
Yep.
Um, for the audience here, if you have any more questions for Charmaine or for me, please put them in the chat section. I think we'll wait for another 2 or 3 minutes. In the meantime, you can switch on your cameras. We can take a group photograph of all of us together. I think life after COVID, it's made it easier for everyone to connect online. And this is one small exercise that we do with all of the webinars that the academy conducts. That we click a group photograph together, which is like a nice memory that we've attended this wonderful session together. Charmaine, there's one question which talks about positive pressure being of help in smaller IVF laboratories. All of,
Yes.
all of the labs that you mentioned were quite large, but if it's a small space catering to,
Even even a small one. So the smallest lab I've done is about 50 square meters. So not very large at all. And even then we had positive pressure in there just to be able to push contaminants out of the space, to make sure that contaminants are not being sucked into the lab. So regardless of the size, positive pressure, even if you can't reach 30, at least have more pressure so the air is getting pushed out, is of an advantage, particularly for contaminants. Yep.
absolutely. Okay, I don't think there are any more questions. I'll just wait for a couple of more minutes for any of you who would want to be a part of the group photograph. Thank you, Charmaine, for that wonderful lecture. Actually, both lectures were quite enlightening. And guys, if you want to follow her work, you can follow her on LinkedIn. I did post her LinkedIn profile in the chat section, and you can see the kind of labs that she's building and maybe consult her if you would need some advice. Vikas, we can take a group photograph.
Right, sir.
Thank you, everyone. And whatever topic you would want to now have me host next, uh, please send them to us on email or on the WhatsApp groups, and we'll be happy to plan something for the future. Thank you to our sponsors, Shivani, for always being so supportive. And they're the ones who are doing most of the laboratories in India, Charmaine, if I may use them to you. And
Yep.
they build these
Cool.
wonderful laboratories with Indian concepts and like Indian made products, and really innovative like stuff being brought back
Fantastic.
into the country.
Wonderful. Wonderful.
Okay, thank you everyone, and
Thank you, everyone.
okay, bye bye.